Okay, welcome back, everyone. We've got a remote presentation about to commence. It's an interesting topic, this one. Fibre-in-pipe technology, and we have got Greg Whitton and Marek, who I'm sure many of you will know as well, that are going to be speaking on this particular topic. So if you'd like to bring that up on screen, we'll let that run. Thank you.
Hi, my name's Greg Whitton. I work for CloudNet IT Solutions, and I'm here to present the fibre-in-pipe technology for you for today at the LINX event. Just a little bit about CloudNet. We're a wireless internet service provider, and what we actually do is we do fixed wireless access. We also work alongside BD UK and the Scottish Government's R100 scheme, and we are a supplier of that. We provide fibre and fixed wireless access to both business as residential properties. We also provide ship-to-shore communications. We deliver comms to the aquaculture sector, mainly salmon farms, which is both communications and sensing devices. We also have a full network of IoT gateways and sensing across the whole of the Orkney Islands. Our fibre infrastructure providers, we also provide fibre to the local authority and also to the NHS, so we don't just do business as well. Part of our workload is we undertake innovation and testbed and trials. Originally we started off doing TV whitespace back in the days of 2014 when we decided to use the whitespace to provide internet connectivity to passenger ferries. So when the digital changeover happened, we decided to put that onto our ferries, which was a successful trial. Moving from that, we worked with our partner Strathclyde University, Faelix, Cisco Systems and a number of other ones, all to do with delivering of 5G trials. Of these trials, both of them are listed there, 5G Rule First and 5G New Thinking, which was successful under the DCMS scheme. So for you, where is Orkney? Orkney is in the very north of Scotland, so we're 6 miles north of John O'Groats. And as you can see there, the circle there indicates it. But putting this into context, if we overlay Orkney into London area, you can see that the main airports are listed there. And we are approximately 60 miles long by about 36 miles wide. And when you squeeze us into the area of the M25, you can see that our testbed and catchment area is slightly larger than it is for the London area. As you can see, this is our core network. The red cells that you see are all our 5G testbed and trial cells that we have across Orkney. We have 6 in total. We have also the green cells, which are our fixed wireless access, which provides both radio links as well as 5 gigahertz access across the network there. And you'll also then see that we also have DIA access in 5 areas there, and you can also then look at the subsea fibre that we have, which is joining our networks together. So let's talk about fibre technology and why. Why did we do it? We're doing on Papa Westray a full fibre programme here, and we had challenges with the planning and the archaeology societies. The council planners, through the archaeologists, were basically concerned about all the Orkney Neolithic history that we had. And in Orkney, when you'll see a map later, we've got burial tombs, historic settlements and sites of historic interest, all of which they were concerned that we were going to destroy or upset. The Council Roads Department too were unwilling to allow us to use the grass verges and or do road crossings. We're not entirely sure why, but I think they were also fearful that we were going to interrupt the BT infrastructure that's on the island. So then we looked to solutions, we looked to innovation, and this was using water. By using water, we meant by putting fibre through the water network to allow us to travel long distances to deliver fibre to areas where we weren't necessarily allowed to. Benefits behind all of this. One is we also found it reduces costs. It reduced the need for road crossings, road closures and any excavations, and also reduces our carbon footprint from machinery used through to having to do any other types of excavation where carbon would be wasted. Wastewater is also another side to what we can now deliver. So through the fibre and the systems, we have a potential now to then identify any water leaks that are coming through with adding further fibre into the network. It's also improved communications for our local community by utilising the water network. As I mentioned previously, you can see these are all the archaeology sites in Papa Westray, and as you can tell that there's over probably about 150 of these sites, all of which our fibre was going to be passing by somewhere. In terms of Pappy, where is Pappy? Well, you can see Pappy, we're zooming in, it's in the very north of Scotland, in Orkney there. The demographics behind this is approximately 60 properties. It's about 5 miles long and about 1 mile wide, sorry. The water supply is a privately managed water supply, so the island basically generates and maintains its own water system. They have 1 header tank and 5 pumping stations with tanks. This provides 100% of the water to the islands, and of all of this we now use all the 5 pumping stations in order to deliver fibre and the water. These are the properties you see here at the moment. So this, as you can see, we're not exactly just doing a part of the island, we're doing the whole island. And so the water network has actually basically taken in the majority of this. The pipe network itself, the fibre. Okay, so we've used about 3 miles in total of the water network. The pipe diameters we've used range from 63 down to 25 millimetre. The 25 millimetre is the smallest supply we use, of which is basically the one that goes to the properties. The fibre inside the pipe is about 5 millimetres with a 2.5 millimetre internal diameter. It comes with 4 core single mode pre-blown fibre. However, some of the capacity we found wasn't enough for us, so we decided what we would do is blow that fibre back out, and we blew in 12 core instead. Wasn't part of the recommendations, but we managed to do so, which is quite a success for us. On one of our locations we needed more than that, so we decided what we would do is blow 2 fibres down the same tube to the well and break out in the well, giving us a capacity of 24 core for our network capacity, all of which was on backhaul. The 5 wells pump basically the water to the header tank. We've also added in IoT sensors into this system for the water board. Now they can monitor water temperature, water pressure, and they can also remotely turn on and off some of their water pumps on a need-to basis. The network is designed principally with fibre as a backhaul solution, not fibre to the property. We decided we would challenge the network, and we'd also utilise what we could by providing a backhaul network through this water system. And this is something that we believe are the first in Scotland to deliver, if not the first in the UK to deliver. The system and the network is fully industry approved, so as you see on the screen there, these are all the industry approved regulators. So what we are delivering is a system that is regulated and approved to utilise in water networks. This map shows basically the fibre, the water system that we've used in the north of the island. So you can see the blue lines. The blue lines is the main water network that we've pushed the fibre through. This is over 1 mile long. And in the south, we've used an extensive network here of joining a couple of the wells in, but also utilising a backhaul network that takes us all the way down to the pier and into the east side of the island. Some of these runs were just under 1 kilometre in length. So installing fibre into the water, what's needed? As you can see in the picture on the right hand side, this first step is know your water network. There's so many aspects you need to take into account. You need to know where valves are, where the water joints are, any air valves in the system, fire hydrants, the routes and the depths that these water networks go, and also looking potentially at the design of the valves should you need to understand if the fibre is going to flow through those valves successfully. Not knowing will also cause you difficulties. Primarily it'll cost you time, effort and money to find out what's happening there. The step 2 is to excavate the water pipes, keeping a good clearance all around top bottom. You need to make sure that you have the capacity to actually work around the pipes, so this is why we're saying that. The third is shut the water network off. You cannot work with the network under pressure, otherwise it just causes problems and also a risk to the workers around you. So you have to drain the system next. If draining is not possible, then we say move to step 5. Drill a hole where you're going to exit the fibre out of the water network, which is probably downstream of where you are. Stand well away and let the water drain out. This could take time because it's a compressed system, so make sure that you do, and you know that that's going to be an empty network once you've done that. And the rule of thumb is always go with the flow of water, never pull fibre through the network against the flow of the water system. In this picture here, you can see this is one of the steps with the holes already been dug. The pipe, the area has been excavated. The water pumps there just draining any excess water out. But you can see we're actually preparing the saddle there for fitting the water pipe. The step 6 is at the receiving end. Now, bearing in mind that when you do fibre in the water, you should only run up to about 1,000 meters, primarily because you're going to hit valves, you're going to hit joints, you might hit some junctions. So if you're going to go any longer, then you want to make sure that you can work within reasonable sections. The 7th step is to prepare the fibre and secure a sponge or kite. The kite or the sponge is a means by which you use this to draw the fibres through the water system, and it is sized to fit the internal diameter of the pipe, so you must, hence why you need to know your documentation. Fill the saddle, fit the saddle and fill the saddle with the sterilisation fluids which you are given. It's there to ensure that the sponge and the kite are sterilised prior to going into the water, so that there's no contamination in there. Step 9 would be to fit the sponge into the kite and then fit it into the water system. Lock it down and you're ready to then run the system. When you install the water valves, you have to do this at the end site. You have to do this in order to drain the water away from where you're working. What you don't want to do is work in an area where it floods. So you need to make sure that this is taken away when you're working through the network. As you can see here, you can now see in that picture that saddle is now fitted. The cleaning pot and the fibre is ready in preparation for blowing the fibre through the water system. And at the other end, you can see the sterilisation is being prepared. The valve and the drain valve has actually now been fitted, ready to turn on and pressurise the network. Step 12 is pressurise the water system, so basically turn the water on. Once you're ready, receive the open end and allow the water to flow. This will come out via that blue pipe, and once the water pressure starts getting into the system, the fibre will start pulling through the network. See below, you'll see the video. This is, you can see, this is the fibre actually going through the water system now. So you can see that it's being pushed through quite nicely and quite successfully and quite quickly. And you'll see that the other guy there is actually just making sure that he's in communication with the other end and that the fibre is coming off the drum successfully. Okay, receiving the fibre is literally just weight. There's going to be lots of water and there's going to be lots of air. The fibre, when it goes through the network, will definitely stop when it gets to you. So if it stops, it just means that you've literally got there or you've got a blockage. You just need to work the network through. The spongeal kite, when it's successful, will come through the water valve and will come out the blue pipe. When this happens, the fibre will stop, hence why the radio communication. If there are no issues, then this is the work. You can just finish off the work, complete it. Time dependent as well, you need to look at that. Depending on the water pressure and the distance you're going, the more water pressure, the faster the fibre will go. So it's just trying to work that out and having some patience. 16th step is to ensure that there's enough fibre presented at each end of the splicing. It is critical. What you don't want to do is cut the fibre too short or too low. You need to make sure that there's adequate fibre and tails at either end to ensure that you can continue splicing. As you can see in this photo here, you can see the blue pipe there on the rock, and what's come out is the sponge and the fibre is now there. Just to give you a presentation, this is an evaluation unit we have. As you can see, there's the two saddles. That's the fibre that's in the middle of it at the top. And you can see it's now been dressed through into the system. So that's in principle how it works. The two yellow and black items at the top are gas plugs, so they're there to stop any water or gas going through the system. These two photos you can see on the one on the left is the sponge and the Chinese fingers. The Chinese fingers typed to the fibre, which you can see we've left sticking out there for you. That's what's used to pull through small pipes, and if you've got any larger water systems, you then use the kite, which you can see there in the blue and the yellow, which when you flood the network, it will then actually act like a kite, and it'll take the water and pull the fibres through. What happens when it goes wrong? This is why I've stated you need to know where your fibre is. If you can't really detect it, so you need to have a rough idea where it is. And if the network is known, you then need to break the network down, open up valves to determine the joints for some reason. And in closing, fire hydrants. We've mentioned this before. Due to the designs, water is expected to exit with maximum force. We came across problems with the fire hydrants, and the sponges got caught up in these, primarily because of the design. So, if that's the case, always be prepared to get wet, understand your issues, recruit people who are willing to get wet. And I say this because we had to do this in the middle of the night, trying to get the water network back up and running. And we recruited a young girl called Emily to locate the sponge, feed it through the hydrant to allow the fibre to go onwards. And the only reason why is because her hands were small enough to deliver this, to find the sponge and feed it through the fire hydrant and then take it on. And as you can see in these photos here, you can see that Emily's lying on the ground. Somebody's actually trying to hold her legs up straight because of the position that she was in. And you can see there again that she's then trying to feed through. It's not a good photo, but she's trying to feed through the fibre whilst we're trying to get that in place. Thank you very much. That's me done for today. I'm now going to hand over to Marek of Faelix, who will now do the 5G aspect of the Orkney CloudNet systems. Thank you.
Thanks, Greg. Hopefully everyone can see my slides and hear me. I'll get started with 5G and FTTP, some of the technicals. So many of you will know me. I work at Faelix. We're a consultancy that helps altnets. We're also a LINX connections partner. And I'm a big believer in spreading good network engineering clue and passing on knowledge to clients and colleagues. So fixed wireless access and FTTP. When we got involved with these projects up in Orkney, the first part of our work was to do a network redesign. And there is a much longer talk where I cover this in great detail that you can watch on the UK North YouTube stream. But roughly, there were a series of regions where 5G was being deployed initially, with uplinks, the internet connectivity coming in at core POP sites. Most of the links between the POPs are wireless, fixed wireless or managed spectrum type stuff, but there are a few fibre links between key POPs. And Greg's already said about fibre builds. The fibre build here in terms of this AS map is the top left one, and that's Papa Westray, but there are a couple of other deployments that CloudNet are also working on. When we designed their network, we took the approach of not having any pets. So the idea being equipment is very, very standardized. It's going to be easier for sparing and automation, and to try and template the way we do the configuration. And I go into a lot more detail in that UK North talk. A typical day would be, we would grab the gear that we were going to deploy at each POP site or aggregation site, pre-configure it, box it up, and then either drive to site, or as Greg already mentioned, in the case of Pappy, there isn't a way to actually roll on, roll off there. So you either take a boat, or Papa Westray is famous for the shortest air service, which is, I hate flying, so it's absolutely terrifying, all 90 seconds or however long it lasted. But that is the other way to get to Papa Westray. And then you get to site, and site has to be a reasonably weatherproof environment on Orkney. It's one of the engineers there described the rain as being vertical upwards. We were blessed by an awful lot of sunny days, which meant it was quite nice and pleasant to sit outside and configure up networking and radios. But occasionally there were only just nice days where the rain blew into your face and you absolutely had to button up. We didn't actually encounter any not nice days. We only had good weather, but it can get quite blowy out there. Here's one of the most complicated POP sites. This the equipment at the bottom of this is the 5G network, but that's gradually being replaced with the fixed wireless access equipment. Now that, sorry, not fixed wireless, with the FTTP aggregation equipment that is using the fibre to pipe as part of the backbone. In terms of access technology, during the 5G trial, we found that there wasn't an immediate take-up and a huge usage of bandwidth. And we attributed that to users just not having had the ability to stream, obviously didn't have things like Netflix subscriptions. So the average use was very, very low compared to Ofcom's average. However, now that 5G got deployed with fixed wireless access to most of Papa Westray, that bandwidth usage started to climb up. And the technology that was used would provide between 1 and 300 megabits of capacity, which should be shared across about 60 homes on Pappy. But how long is that sort of capacity going to be relevant, given the figures that the Ofcom cites of 1.5 megabit average? By the time you do your calculations, that's going to need upgrading within a few years. So for the FTTP network, we tried to standardize on the access method in terms of how customer CP connects. During that legacy network upgrade, we moved the access method to be PPPoE so that CloudNet could deploy a central radius authentication system. Most customers get CGNAT with IPv4, but they also get native v6 by prefix delegation. For customers who need IPv4, PPPoE gave us the advantage of being able to save IP addressing, as CloudNet only have 1/24 of their own. And it would have been possible to use the radius authentication with the 5G core, but that wasn't necessarily for the trial. Elsewhere in their network, they were using radius with PPPoE, so we wanted to treat FTTP in a similar fashion. On Pappy, because of the density of properties, they're actually using dedicated fibre to each customer, but had they used a PON technology, it would have been very similar. And that would have been just treat each tail or each PON split as a sector of a radio, effectively. Exactly the same sort of architecture, which meant that going forward, as they deploy PPP, as they deploy FTTP, it's as simple as unplug the radio and plug the CP into a media converter, and the PPP authentication just goes straight through there. And it also gives CloudNet the ability to consume wholesale services from the likes of BT and the incumbent, because they can consume the same ONT type handoff for FTTP or even SIGIA type services. In terms of results, customer performance went absolutely through the roof. The national incumbent can provide less than 1 megabit per second ADSL on Pappy because of line lengths and how their backbone works. But we saw one customer regularly hitting 150 megasecond as he was downloading all of the games for Xbox or PlayStation. I can't remember which one. It simplified network manageability because they could manage their allocations from radius because they've moved to this PPPoE based system. And we'd managed to improve the network such that they've got layer 3 routing rather than relying on things like spanning tree, which improved resilience on their backbone for rain and tide fades, which are not uncommon given the weather up there. In terms of the team, it's a project that involved loads of people, and some of which are pictured in these two. So whether they were climbing towers or grubbing around in the mud pulling fibre out of fire hydrants, it was something of a community project. And other than that, I'd like to say thanks to everyone and be very happy to discuss last mile in the questions now. Cheers.
Okay, yeah, round of applause, I think, for Marek and Greg. Do we have any questions on this this particular topic? Surely we have some questions. Okay. Well, yeah, I thought it's a really interesting talk. It's good to actually hear the different ways that this is being done. Can you see this being used in other areas? Are you in discussions with other organisations that could be doing something similar?
Well, what we've been doing is we've been lobbying the Scottish Government, because the Scottish Government actually didn't realise we'd put this system in place, and they're finding that we've gone and done something innovative again. So we are now trying to leverage this and speak to Scottish Water themselves to say, look, this is a way forward for providing connectivity to rural areas, even to the point where if you can break out near a mast site, you can then start doing FTTP to a tower a lot cheaper than you can than having to just physically dig fibre all the way to the site from somebody's pop. So yeah, we are working with it, but the problem with the likes of Scottish Water is that way leaves are a big problem there, because water isn't there for communications, it's there for water. But so we're trying to look at that, but there are other ways we're trying to leverage into their networks by saying this is good for leak detection. There's a lot more savings that can be done this way. DCMS themselves are quite keen and involved in it. So yeah, there is a lot more that we're trying to leverage. But at the point you leave a water meter, I think if you have long runs and you're trying to do FTTP, this could be used on anybody's farmlands or properties, in particular in rural areas. So there is quite a lot of interest in this at that moment.
Okay. All right. Thanks so much. Oh yes, we do have a question in the room.
Hi, Ian Dickinson from Vitrify. I was wondering if you'd had enough experience with the in-life and what sort of faults and other impacts you might have there, and whether they were really nasty or easy to resolve.
I'll mention on the fibre side of things. At this point in time, no. The in-life is about 20 odd years, because it's PVC. It's been tested to a long life, and water's constantly moving, so it's constantly cleaning itself at that point in time. Any problems we've had, primarily none so far. When or if we expect a burst, that's where we're going to probably end up running into problems. But it's simply fixed. Primarily, you dig the hole, you then just basically put two saddles at the either end, you then push the fibre through, you make the decision. Do you blow fibre, do you just resplice on, and then just put it back on the other end, and away you go? Or you bypass a valve. That's more or less at the moment.
Okay, we've got another question in the room here.
Hi, Ivan Beveridge here. Just touching on something you mentioned, actually, I was just wondering of how you find you have to kind of insert yourself into the idea of if there's a pipe failure or a waterway failure, that you kind of perhaps have to get notified first or early on to make sure that somebody doesn't kind of like cut through the pipe and consequently cut the fibre without your knowledge. Thank you.
Yeah, for us, that's not so much of an issue, because the local team we work closely with it, and what we insisted on doing at the time is we used these guys to actually help us build the network so that they understood what we're trying to do. So the first port of call is if they do know there's a burst, themselves are trained in dealing with the problem. We'll then know what to do, and we can then just send out the relevant stuff needed to either splice it or just reblow the fibre.
Okay. A question from Simon.
Hi, it's Simon Lockhart here. The pictures you showed of the water pipes were quite large diameter. Is there sort of a minimum diameter that this really works with? The other question is that the saddles and things you use, are they off-the-shelf products, or did you have to have them manufactured to meet your requirements?
Okay, minimum, you can go up any diameter. The smallest diameter was the FTTP actually to the properties. That was the 25mm diameter. We did struggle with that, but primarily because the saddles we were using, they went into the pipes themselves, so it kind of jammed the fibre as it's pushing it through. So we had to end up having to cut it. But we would have struggled if we didn't have as much if we didn't have water pressure. If you don't have water pressure, then you're going to really, really struggle with it. The saddles, they're made to order. Basically, they're made to order on the size of the pipe dimensions that you need, and we use a supplier in the UK for that.
Great, thanks.
Yeah, we've got another question here.
Hi, James Knight from Zayo. One of the queries I've just got is, you mentioned it before about keeping it sanitized, but did you get any feedback from the end, like the households, with regards to contaminants, with regards to any contaminants that could be placed within the water supply from the cable, and how you overcome that?
Yeah, okay. We've had no queries or complaints from the actual home users at all. The water system that they use, because it's a private water system, isn't treated like you are in a normal city. They don't use chlorinization and other chemicals. It's done using UV lamps. So ultimately, at the source, all the water is actually purified when it comes out via the UV lamps. In terms of when we used the chemicals, it was all when you're flushing the system through, when you're putting the fibres in place anyway, once you've got the fibre to where you want, you just literally just let it run for an hour or so in order to clean the pipes and make sure that if there has been any dirt that's gone through, it comes out via your pipes that you've done yourself prior to closing it all off again.
Thank you. Oh, is this still working? Thank you. The second one I had. Oh, sorry. The second one I had was, if in the event that you've got burst pipes and from a water supply perspective where they've got to cut out sections and replace it, I'm guessing the only way you're going to be able to do that is effectively re-terminate the fibre either side of the break, because if they're going to remove a section of piping, it's going to cause you, well, some disruption and also some challenges.
Correct. Literally, you just cut back the fibre, pull it back to the point, put a chamber in there, do some splice joints, splice chamber, and move on from there. But that's the beauty behind fibre. You can have a number of splices, and you know, your losses may be there, but ultimately you test those losses at the end of the day. Or alternatively, I think I said before, depending on the distance from where your last splice joint is, you'll either just then re-terminate, rejoint the pipe, and loop it through. So you just blow new fibre back from one chamber to the other, to the chamber again, and just replace the fibre completely.
Thank you.
Okay. Oh, we have another question from Jen.
Thanks. Yeah, Jennifer from LINX. I was just wondering about the community side of it. And you said there were 60 properties on the island. How did you go about communicating with these residents? And what can you give us an idea of the demographic of the island? Like, is it how much of the population might be elderly or younger, and how they reacted to this project, and what support or objections you might have received from them, and just that communication side of things and how you went about that?
Marek might be able to help out with this question as well. We basically spoke to some key representatives on the island, from the water board and also from the community council. We didn't really encounter too many problems, because ultimately, when you're looking at what the broadband they had originally was, I think the whole island and 60 properties that's just there. So the demographics, 60 properties, about 100 people. Age-wise, anything ranges from 90 through to 18, but there's only about 5 or 6 young adults under the age of 25. So from that point forward, everything's a bit in between. The island at the time, prior to us delivering broadband or fixed wireless access to the island, was approximately 0.5 meg to everybody's homes, and BT, the incumbent, I should say, literally delivered 8 meg, I think, to the island in total for the island to share. So, you know, we've come along and we've said we're going to do FTTP, fixed wireless access, followed up with FTTP when we can, to give them a minimum of 40 megabits per second and 20 megabits backup. And so in terms of receiving, the island was receptive for one person. The only person who wasn't receptive was somebody who used two-way or satellite, and he preferred to use that rather than anybody else. And he didn't trust what we were doing, despite the fact we've had to sign up to the Scottish Government's Fibre Charter scheme to ensure that we meet the standards as any other provider does.
Yeah, to follow on from that, during my work there, I'd say that the general reaction from local residents of being given something that was, you know, orders of magnitude better than what they'd previously been used to varied from elation through to literally tears of joy of, my God, finally, you know, we're brought into an age where we've got modern communication, that we can get access to all of these services and, you know, communicate so much better. So, yeah, I'd echo what Greg said. I don't think there were really any challenges from the community. Far from it. More the opposite of brilliant. This is excellent work you're doing. How can we help in some cases?
Yeah, to add to that, we've also got a Ukrainian family on the island now. So the Ukrainian family, the lady who's there with her 6-year-old son, she now is online and actually is an online lecturer back in Ukraine. So she's now able to carry out and fulfill her roles whilst supporting a child on the island. We've got people now who do online consultations, training, and have actually changed jobs now. So they've actually moved away from cities and come to Pappy, primarily because they can now do their jobs remotely without any problems. And they're finding that the communications that we're providing through the systems that Marek's designed for us has actually been far better than what they're finding when they were in rural or urban areas on the mainland of Scotland or the UK. So it is actually a very positive approach that we're trying to deliver here. It's just costly, time consuming, and actually very rugged, I suppose.
Okay, thank you. Have we got any last questions before we go to the next session? Okay, Greg and Marek, thank you very much indeed.
Thank you.
Thank you very much.